Hey kids, Mr. Glenn here, hope you are well. Today we are going to be exploring technology and computers without a computer. A part of learning about computing is the art of programming or logical thought. One of those tasks is really super simple. It is the game of cup stacking. Now, cup stacking, you may think, is relatively simple. We can just put our cups down in front of us and we can stack them up, okay, and we can bring them back to the stack. However, putting that into practice with logical thought is really quite tricky, and you're going to have to work with a partner to come up with a language that is similar to this. Now, you're going to have this with you, so this is our language, okay? It's just arrows at the moment. And if I read this to you, because it may have been back to front on the camera, because I'm using the front-facing camera here, we've got pick up cup, which is an arrow up, put down cup, which is an arrow down, step forward, step backwards, and then we can go and turn our cup 90 degrees. Okay, we turn it 90 degrees either this way or that way. Okay, so right or left. And the reason we're going to do that is because we have a series of challenges with our cups. Okay, so I've circled number 1 here, and it is the basic 3-cup triangle. Okay, you can see here we have another one, number 2, or even which way you're going. You can see that the cups have been rotated either right or left. Now, your task is to use your whiteboard, and you can see I've started here, by using the symbols to create a sequence or a syntax of strings of symbols. So when we use those strings of symbols, it means that when I go and bring my cups and pop them down like this, so there is my 3-step operation: pick up cup, move across, and put down. Oh no. You see, I've only gone half a cup, and the rule is that for a single movement, either left or right, equals 1/2 cups width. So here I would have to go and put a second one in with my pickup cup, move left, and place down, meaning that I can pick up this cup as long as it isn't stuck. One move, and down. Picking up my other cup this time and moving it 1 space and placing it down. Now then, so far so good. However, using our basic syntax here with our symbols is easy so far for this, because we can rotate our cups relatively easy. So when we move from the easy version to the harder versions, we're going to need more cups. Now, in our class, we will have lots of cups so that we can start to expand what we've got. Finally, those of you who are looking at these pictures may notice that there are some patterns, and some of the patterns repeat themselves. In these symbols, there are groups of symbols that we can put together in order to make a repetitive sequence. This is called a function. And in our function, now the F and the N may be back to front, I'm ever sorry about that. The F and the N here can stand for function. You could just have the letter F. I've put FN and a number here, or a pound sign or a hashtag, to represent how many times I'm going to have to repeat that sequence afterwards. So it may be 2. I may have to repeat that sequence 2. However, how do I know what the function is? How do I know what the symbols mean? And if I make up any extra symbols for my syntax, how are the people next to me going to know how to run my code on their table? Somehow, we're going to have a universal language. How you do this and how you collaborate with other people is entirely up to you. What languages and symbols you use beyond this is entirely up to you. However, when I give my code to another table or to another group, they must immediately be able to repeat the language and the code in that piece and make exactly the same thing as I've made here, using the same language. How you do that is entirely up to you. But the key to this is teamwork, communication, logical thought, and most of all, and most important, collaboration. Right, my little cherubs, I hope you all and wish you all the best. I hope you do really well, and I wish you all the best. As always, good luck.